Guys, today we're going to talk about solving right triangles by using inverse trigonometric functions. So, given the equation sine theta equals x, theta represents an angle measure, which is the input. X represents, in sine, opposite over hypotenuse. In cosine, it would be adjacent over hypotenuse. Tangent would be opposite over adjacent. No matter what this is right here, sine, cosine, or tangent, this x will always be some ratio of sides. And that is the output. When we find an inverse, or when we use an inverse, instead of putting in the input and getting an output, we put in the output, and the inverse gives us the input. So when we use a trigonometric function, or an inverse of a trigonometric function, what we end up getting is going to be the input, or the angle measure. There are a couple different notations for a trigonometric inverse. One looks like this: sine with a -1x, cosine the same way, and tangent. That's one notation for a trigonometric inverse. Another is like this: arc sine x, arc cosine x, and arc tangent x. Both mean the same thing. The second way is just a little bit more formal. Using a calculator, solve each problem rounding to the nearest tenth. Okay, so we're given lowercase c, so that's side C is 7, side B is 4.5, and we want to know the measure of angle B. So here I have my angle. This is opposite and hypotenuse, so I'm going to use sine. Sine B equals the opposite, 4.5, over the hypotenuse, 7. The input, the angle measure, is the variable, so I'm going to use an inverse. So B is arc sine, 4.5 over 7. This is where I'm going to have to cut out a portion, not the end of the world. So we've got our calculator ready, and first thing I want to do is check my mode. So we've got our calculator ready. First thing I want to do is check mode and make sure I'm in degree. If radians is highlighted, we need to come down and highlight degrees and then clear out of this. I'm already in degrees, so we're good to go. So here's how I do arc sine 4.5, second sine 4.5 divided by 7, enter, and I get 40.005. It does say nearest tenth, so that would be 40.0 degrees. And even though I have 0.0, I do want to actually write that 0.0 to indicate that this is not exactly 40 degrees, but it's rounded to 40 degrees. Number 2, if A is 11 and B is 20, find the measure of angle A. This time I've got opposite and adjacent legs. So I'm going to use tangent. So tangent A equals the opposite over the adjacent. Again, it's the input, the angle, that's the variable, so I'm going to use an inverse. So A is arctangent, 11 over 20. So in my calculator, second tangent, 11 divided by 20, 28.8 degrees. And for number 3, C is 14, A is 10. Find the measure of angle B. So this time I've got the adjacent leg and the hypotenuse. That means we're going to use cosine. So cosine B equals the adjacent 10 over the hypotenuse 14. And once again, it's the angle that is the variable. So B is arc cosine, 10 over 14. Second cosine, 10 divided by 14. 44.4 degrees. Number 4 and 5, solve each triangle, rounding to the nearest tenth if necessary. Solving a triangle means, in the end, we need to know all 3 angle measures and all 3 side lengths. We're given here that C is 90, so I don't have to worry about angle C. B is 52 degrees, and side A is 4. So let's find side B and C, and then we'll do the missing angle. So in order to get side B, I've got a 52 degree angle here. Opposite over adjacent is tangent. So tan 52 degrees equals the opposite, which is B over the adjacent 4. When I've got a number down here, I just need to multiply that to both sides. So I'm going to get 4 times tangent 52 equals B. Let's clean that up a little bit. That pen doesn't go that low. Let's move on. 4 times tangent 52, 4 tan 52, 5.1. Now when I find C, I want to avoid using that 5.1 because it's rounded. So I'm going to use the 52 degrees and the 4, and that would be cosine. Cosine 52 degrees equals adjacent 4 over hypotenuse C. So to get C by itself, I can multiply both sides by C and then divide both sides by cosine 52. What that does in the end is it switches these things diagonally. I can switch diagonally like that anytime I want to. So C is 4 divided by cosine 52. And 4 divided by cosine 52 equals 6.5. The only thing left is to find angle A, and I can do that by doing 180 minus the 2 angles I know. Triangle always adds up to 180 degrees. Minus 52. 180 minus 90 minus 52 is 38 degrees. Okay, so the missing things that I've had to find, B, side C, and angle A. In number 5, angle A is 18 degrees. Side B is 11. Let's do side A first. Opposite over adjacent is cosine. Opposite over adjacent is A over 11. When the number is here in the denominator, I'm going to multiply it across. 11 cosine 18 equals A. So 11 times cosine 18 is 10.5. Okay, now C, I don't want to use this rounded number, I want to use the exact number, so I'm going to use cosine adjacent over hypotenuse. So cosine 18 equals the adjacent 11 over the hypotenuse C. And anytime I've got my variable in the denominator, I want to switch these and divide. So C equals 11 over cosine 18. 11 divided by cosine 18 equals 11.6. Okay, the only thing left is angle B. So 180 minus 90 minus 18. And 180 minus 90 minus 18 is 72 degrees, and that is angle B. I now have all three sides and all three angle measures on that triangle.